Hello and welcome back to the Flutter series. This is the second episode. In the first episode, we set up our coding environment. We now have our IDE, we have our SDK, and we can run an app. But we haven't actually learned the language that controls it all. That's where Dart comes in. Dart is the language which we use to code Flutter UI. Today, we will dive into core concepts of Dart that you need to start building Flutter UIs. We're going to start by directly going to the compiler and firstly learning about variables and data types in Dart. I've opened up an online compiler for Dart programming where we can run simulation code for Dart. The first thing that we need to learn is variables and data types. But before we do that, let me just explain what we have on the screen here. This is the void main function. So there's two keywords here. There's void and there's main. Main is a function that Dart looks for every time it tries to run a program. So whatever your program has, everything needs to be inside the main function. If you have anything outside the main function, and if it's not being called, then that code will not be executed. So everything that you code will be inside the main function, or the main function will be calling another function. The keyword void refers to a non-returning function. This basically says that we're not expecting main to give any output. So the main does not return anything. Everything executes inside main and everything finishes inside main. Now that's out of the way, let's start with variables. If you're familiar with programming, you know that a variable is simply a container that holds a piece of information. Dart is what we call a strongly typed programming language. This basically means that for every variable that you create, you have to explicitly mention its data type. If you want to create a variable called name and store the value Flutter, this is not allowed because you haven't explicitly mentioned the data type that name is. Now, if I explicitly mention the data type string, then it allows me to store the value Flutter inside the variable name. There's a load of variable types in Flutter, but the four main ones that we're looking at today is string, int, double, double, and boolean. So let's go by this one by one. An int stores a whole number, an integer. So version is a variable with the data type int that has the value whole number 4. A double stores a floating point value. So rating is a variable with the value 4.7 assigned to it with the data type double. Bool basically means Boolean values. It's either true or it's false. Now, currently, if we run this program, we're not going to get any output because we're not actually printing anything. Now, to actually get an output, you have to run a print statement. Print statement is pretty basic in Dart. You can simply type print and type in the name of the variable that you want to print. So if I type in print name, it's going to give me Flutter. You can use multiple print statements. If I type in print version, it's going to give me Flutter, and then it's in the next line, it's going to print 4. Now remember that a string variable has to always be in a double quotation. An int is for whole numbers, a double is for floating point, and bool is for binary decisions, or true or false decisions. Now, there's another keyword that you can use to declare variables, and that's the var keyword. There's some advantages to using the var keyword. A var keyword is a globally scoped variable. Now we will talk about what globally scoped variables are once we start with Flutter, but for now understand that it can be accessed throughout the file. The way that you can declare a variable using var is you type the keyword var and then the name of the variable. So let's say language. Now you can directly assign a value while initializing the variable or declaring the variable. So if I say Dart here, this variable now holds a string data type. So this variable is now converted into a string data type. If I try to print this, if I try to print language, it will return Dart. But what that means now is that if I try to assign another data type to this variable, this will no longer be allowed. This will say a value of type int can't be assigned to a variable of type string, because this variable already has the data type string. But we can overcome that by simply declaring the variable. Now, we're declaring the variable, but we're not assigning any value, so this variable is not initialized. To assign a value, you can simply assign a value. I am now assigning a value of int. 5 is a whole number, so language is now holding an integer value. But this value can change throughout the program. So if I now assign it Dart, it will now hold the value of Dart, and this variable changes into a string data type. That's something interesting about Dart programming language. Let's have a look at functions. For example, if I want to create a function that adds two numbers, I'll simply start by giving the function its name, small braces or parentheses to specify the parameters. So I'm expecting two numbers, a and b. Give curly braces to define the function body. Inside the function body, I want to perform some kind of operation with these variables that are passed into the function. For the purpose of this function, I want to return a plus b. Note that I use the keyword return. This means that when I call this function, I'm expecting something in return. For this instance, I'm assuming that a and b are integers. So adding a plus b will give me an integer value. So I can give a data type to the function itself. This isn't required, however, it is good practice to always know what kind of data type you expect your function to return. Now I can call this function. I can call this function directly by printing it, but there's a much better way to do it. Instead, I'll store it in a variable c. I'll create a variable c, call the function, pass 2 and 3 as arguments, and this will call this function. This 2 will be stored in a, and this 3 will be stored in b. The function returns a plus b, which is an integer value, which comes over here. Now it stores that into the left-hand side variable, which is c. Now we have an error here because we're not actually defining the data type of c. Now that we define the data type of c as int, we now expect integer value from this function and store it as int into this variable. Now we can print c, and the output will be 2 plus 3, which is 5. There we go. Similarly, we can create functions that work with strings, for example. If I give it a name, and if I change the function's name to, let's say, greet, let's leave that int for now. Now, if I want to return, so what I want this function to do is, if I give it a name, I want it to say hello name. So if I give it Flutter, I want it to say hello Flutter. There's two ways we can do this. We can do this by concatenating strings, which means I can return hello plus name. Now there's an error here because I'm returning a string, but this function expects a return of int. So if I change this to string, it will now be accepted. So this will work as is. For example, now if I directly print greets, and if I pass in Flutter, this function will return hello Flutter. Now, What is actually happening here? Inside the print method, we're calling the greet function. When the greet function is called, it takes a parameter of name. I'm passing an argument Flutter into the parameter name. It now returns hello plus the name that I passed. It returns a string data type and it gets stored in place of this. So now in place of greet Flutter, hello Flutter gets stored and the print function prints that. This is one of the methods to do this, but what if you want multiple variables throughout your string? It's not very efficient to keep adding plus variable plus variable plus variable. So instead of that, what we do is variable interpolation or variable extension. We can simply add the variable inside the string quotation itself by using a $sign and two curly braces and type in the variable name. What this does is it replaces this whole expression with the value of the variable. So now I print greet start. It will print hello start. Right. So this is returning function. These are examples for returning functions. We can also create a void function. Let's create a function called greet. So I can create a function called greet. I don't want any arguments passed into this, so I won't give any parameters, and I just want to print hello world. Now, Dart will actually let you declare this function without having a data type. So this is a perfectly valid function, and if you call greet, then it will print, if you call greet, then it will print hello world, but you get null. So the reason why you get this null is because when you call greet, you're expecting an output. You're expecting a value to be returned when you call this function because you haven't explicitly mentioned that this function does not return any value. And when you're expecting a return and look at this function, it's not returning anything, so it shows null because nothing has been returned. So to avoid this, you put void. The void keyword lets you know that this function, when called, will not return anything. So you print greet as is. You just call greet. You don't need to print it. When I was trying to print it, it was trying to get a value from greet and it couldn't, so it showed me null. Now, when I just call greet without printing it, it will give me hello world. And since this is a void data type, I'm not expecting anything in return. Remember, you cannot create a variable, for example, you cannot create a variable called string and store greet in it because greet does not actually return anything. So there is nothing to store. That's for the void data type in Dart. Now let's talk about control flow statements. Control flow is how we tell the program what to do under different circumstances. We can use if-else for branching logic. For example, let me create a variable called int version equals to 4. Now, I can create a control flow statement to check and compare this version variable to different conditions and output or carry out different tasks based on those conditions. So, for example, if the version is below 5, I want to print version below 5, and if the version is above 5, then I want to print version above 5. For that, I would do if statement, parenthesis, and the condition. So if my version is below or equal to below 5, I will print version is below 5 and semicolon. Else, print version is above 5. If I run this code now, this will print version is below 5 because my version is 4, which falls under this condition. If I, for example, change this to 10, then the program will check if the version is below 5. This will return false, so it will go below the if statement block, below this block, it will enter the else block, and it will print version is above 5. You can use conditional statements in such a way. Let's talk about loops next. So sometimes a problem arises. You want to print something multiple times. For example, if I want to print hello world 5 times, one way you could do that is write hello world 5 times. This will work, and this will print hello world 5 times. It does work, but it's highly inefficient. What if you want to print it 1,000,000 times, or let's say 100 times? It's very inefficient. For this purpose, we use loops. So loops in Dart are very similar to loops in JavaScript. Start a for loop. For loop is a type of loop that you use when you know the condition. So you know how many times the loop is gonna run, so you use a for loop. For I equals to 0. This is our looping variable. This variable is going to change throughout the loop, and it will be checked against a condition. When the condition is met, the loop will exit. I below, let's say 5, and I plus plus. So let's see what we're doing here. We have a variable I, which has the initial value of 0. We're checking if I is below 5. So if the value of I is below 5, your program will enter this for loop code. But if your value of I is above 5 or equal to 5, this condition will be false, hence it will exit this block of code. At the end of the iteration, what we want to do is I++. This means that use the current value of I and then increment it by 1. So the next time this loop runs, the value of I will be 1. And then the next time it will be 2, 3, 4, and so on. Now, the reason why we're getting this error is because we haven't actually declared I. So I can declare I by doing int I. Now, inside the for loop, you can add a code that you want to run multiple times. In our case, I'll be printing hello world. When I run this, I will get hello world printed 5 times. The first time I is 0. The second time I is 1, 2, 3, 4. When the value of I is 5, this condition is false, so it exits the loop. So this is 5 times. Hence the loop runs 5 times. We will be using for loop constantly in Flutter to automatically create visual elements for every item in a list. A class is a blueprint or template for creating objects. It defines the properties such as attributes and data, and behaviors, which are methods and functions that all objects of that class will share. The class in Dart and Flutter can be understood by using the house blueprint analogy. Imagine a class as a detailed architectural blueprint for a house. This blueprint defines what the house must have, but it isn't an actual physical representation of the house that you can live in. It's just a template that you use to make a house. An object or instance is the physical house built from that specific blueprint. Each house is unique. House number 1 might be blue, house number 2 might be red, even though they came from the same blueprint. The same blueprint can be used and reused multiple times to create different instances or objects. While creating a new object or an instance, you need to define some basic properties, such as its name, its foundation, its address, its color. These properties are defined in the constructor of the class. It is a required initial step that ensures every new house or every new object is built with essential starting specifications before it can be considered complete. These may be changed later throughout the program, but they need to have initial values to begin with. A class is a blueprint used to create objects. It defines what data or variables and actions or methods an object will have. In Dart, everything revolves around classes and objects. So let me explain what a class is by a practical example. First of all, we'll create a class called person. To do that, I will use the keyword class in combination with the name person. Notice that the class name has to be written in Pascal case, which basically means the first letter has to be capitalized. Class is the keyword used to define a class. I'll create variables name and age inside the class. So name and age. These are two properties that I expect a person to have. A name should be of data type string and age should be of data type int. These are called instance variables. Every object that I create using this class will have its own copy of name and age. It will have its own unique name and age. A string stores text, an integer stores numbers. Now, a constructor. Every class needs to have a constructor. A constructor looks like this. It will have the name of the class, and in parentheses, it will have this dot the two variable names. So this dot name and this dot age. So what is a constructor? A constructor runs automatically when an object is created. A constructor name must match the class name. This dot name refers to this variable inside the class, and this dot age refers to this variable inside the class. Parameters name and age receive values from the outside. So when you're creating a new object, you have to pass in name and you have to pass in age. The this keyword lets it know that the name and age that you passed in is specific to that object. Class can have behaviors or methods. Behaviors and methods are basically what you expect an object of that class to do. I want a method called greet. So I can create a method. We learned how to do this. I can create a method. It's called void because I don't expect it to return anything. And inside, I just want to greet. So name is age years old. So let me explain this. Void is a method that returns nothing. Greet is a behavior of the object. It uses object's own data, name, and age to achieve something. To finally create an object using this blueprint class. To create an object, you put the class name, you put the variable name, and then you call constructor. In the class constructor, you need to pass two things. You need to pass a name, you need to pass an age. So I'll pass Flutter for the name and 21 for the age. What's happening here? Person creates an object. The constructor runs and assigns values. So it takes Flutter and assigns it to name. It takes 21 and assigns it to age. P1 stores a reference to the object. So P1 stores a reference to the newly created object. I can call the greet function inside P1 object by doing P1 greet. So what this does is it calls this method for this object. So if I run this, it'll print Flutter is 21 years old. Name is age years old. Let's create a new class called student. Class student. I expect the student to have some properties. So I expect the student to have a name, an age, and a college that they study in. The name should be of the data type string, the age should be of the data type int, and the college should also be of the data type string. I need to first declare a constructor for this class. To create a constructor, I use the class name, parenthesis, this dot name, this dot age, and this dot college. Now that I've created the constructor, I can create a method or a behavior for objects of this class. I want to create a behavior that says void study. What this does is it prints name studies at college. Now, if I want to create an object using this class, this blueprint, up here, I will create an object, student. I'll name it S1, and then I'll call the constructor. So student, I need to pass name, age, and a college. So Flutter let's say 25, and college, let's say Harold. Then I can access methods inside this class, which is study. So I can call s1.study, which should return Flutter studies at Harold. But this is redundant. As you can see, name and age are already properties that exist in the class person. There's a simple solution to this, and it's called inheritance. You can use the keyword extends a class. So what this does is that now the class student inherits all the properties and variables of the class person. Student now automatically has access to name, age, and all of its behaviors. So in this case, greet. I can modify variables in the constructor of student class. So I do not need to explicitly mention name and age anymore. In the constructor class, I do not need to pass in the arguments for name and age, but I need to call super. So I need to call super and say name and age. The constructor requires now name and it requires an age. So what's happening on line 32? Student owns only college. So the college variable or the college property is only owned by student. Super name age calls the constructor of person. So when I say super name age, it calls this constructor. So it takes in the argument for name and age. The parent class initializes the parent variables. So since the class student extends person, person is the parent class, and the constructor in parent class initializes parent variables. The child student initializes child variables, which is college. The effect of that now is I can call s1.greet. As you can see, even though this behavior isn't defined inside the student itself, since it extends person, it derivates all the properties and variables of person inside it, so I can call methods that exist inside person. That's all for this episode. We covered a lot of topics in this episode, so it's completely fine for you to get confused along the way. You can go back, look through the topics again, revise the topics again before continuing on to the next episode. The next episode is all about widgets in Dart. I look forward to seeing you there.